acid. Where do I get the colors? Red. All right. Strong acid. As we increase the pH to 3, we get weaker acids, and then 5, 6 will be very weak acids. And where is purple? Okay. A strong base. So the two extremes, 0 is the strongest acid and 14 is the strongest base. All right? Now there's a reason why I've put the colors to it. Except for the normal indicators that we have, where we have litmus and bromothymol blue, we get something known as a universal. Yeah, red, orange, it's violet, red, orange, yellow, blue, indigo, green, blue, indigo, and violet, yes. Well, violet is actually the last one. This is like a blue-purple color. Yeah. All right. Universal indicator is a colored compound that shows by means of a range of color changes the pH of the substance. Now, we get different types of universal indicators, and they each have their own unique color range. The most common one that we use in the laboratory works like the colors of the rainbow. It goes from red, orange, yellow, green, blue, indigo, violet. Okay? Green then being 7, which is neutral. If you look in your books on page 73, there they have various substances. Dilute hydrochloric acid will have a pH of 0. People, sulfuric acid, nitric acid, they are all strong laboratory acids. Their pHs range between 0, 1, and 2. All right. Then, if you go and look at things like lemon juice and vinegar, they are weaker acids. Soda water, even weaker. And then fresh cow's milk, it's just not neutral. Can you see that? It's very slightly acidic. When milk goes off, it becomes more acidic. All right. pH 8, because to prove it's alkaline, they probably add something to it to make it slightly alkaline. It's just because it's a gimmick, because everybody's complaining everything is too acidic, but it's not really got anything to do with the food as such that you eat. Yeah.
This broadcast is made possible by the Capricorn Group.
ShopRite has always been here for you, and our promise to bring you low prices on what you need most will never change. Get 2 kilos Nam milk or Mayere assorted, only $34.99 each, and 175 grams Dettol bath soap, just $10.99, only at ShopRite. One stop, one safer shop.
had a look at the pH range. I said here it's a value that stretches from 0 to 14, 0 being a very strong acid, going up 1, 2, 3, 4, 5, 6 is a weak acid, 7 is neutral, 8 is a weak base, 9, 10, 11, 12, 13, 14 being a very strong base. There's a general misconception that it's only acids that are corrosive. Strong bases are also corrosive, and in actual fact can also be very dangerous in terms of if you spill it in your eyes, etc. Okay, it can also damage living tissue. We use strong bases like sodium hydroxide to unblock a drain. Okay, it dissolves all the fats and it tends to break down hair and stuff that goes into the drain. Okay, so strong bases are also corrosive. Yeah. Okay. Phosphoric acid, nitric acid, they would be quite strong if you have them highly concentrated. No, can't be stronger than 0. Yeah, just hydrofluoric acid of it. Whatever, yeah. No, that's just very strong. The pH will be 0. No, it can't go. We'll have a look at why it can't go lower than 0. Okay, but it's a mathematical calculation. I'll explain it to you a little bit later on. All right, I'm on page 73. Okay, so in your textbooks, there on page 73 is a range of substances and their relative pHs. In your books on page 74, there they have the definition of an indicator. What do we use indicators for? Come on. Yes, an indicator in the first place is a colored compound. And it shows by means of a color change. Whether you have an acid or a base. With me. What are the most common indicators that we work with? Well, the first one you started off in grade 7 with is litmus. Then we work in general with bromothymol blue. Therefore orange. And phenolphthalein. Okay, phenolphthalein. In an acid and in a base. Did we do it? Yes. Okay, so just generally, litmus in an acid is red. In a base, blue. Bromothymol blue in an acid is yellow. And in a base it is blue. Methyl orange in an acid is red. And in a base, orange. Bromothymol blue. Phenolphthalein. Excuse. Phenolphthalein in an acid is colorless. And in a base it's a nice bright pink. Then I said to you, universal indicator. You get different types of universal. The one generally used in the laboratory, coincidentally, I don't know, goes red, orange, yellow, green, blue, indigo, violet, exactly the same as the colors of the rainbow. Green being neutral, red very strongly acidic, and violet strongly basic. Okay. In your textbooks, there on page 74 is the definition of an indicator. Then on the next page, table 5.1, there they show color changes of some common indicators. And now it starts to become a little bit more complicated. Look at litmus. Can you see the change between red and blue is exactly in the middle of that bar. Okay? But for methyl orange, they've written in there, red is the first section of the bar and the second section is yellow. And they say at the stripe separating red and yellow, they say pH 3.7. Now technically you've been taught when neutralization occurs and acid destroys a base, the pH should be 7. It was not entirely true, because if I use a very strong acid with a weak base, the salt that is formed is acidic. And when I use a very strong base with a weak acid, the salt that is formed is slightly basic. And if you go and have a look at phenolphthalein, you will see the pH where phenolphthalein switches is at 9.3. So when will I use litmus? When my acid and base are of the same strength. When will I use methyl orange? When I'm using a very strong acid and a weak base. And when will I use phenolphthalein? When I'm using a strong base and a weak acid. All right. I don't know where it switches. Okay, I think it's fairly in the middle. Okay. Universal indicator, they've got the colors on the chart over there. Usually when you buy universal, it gives you either like a little booklet with papers like litmus, and then there's a chart that you can check and see what it is like, or on the bottle of the indicator, there will be a chart on it that you can compare the color that you get with the chart. Yes, 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 you get a separate little card that you can hold onto the solution to see what the pH is. All right, it differs slightly from one kind to another. Now, the next thing. Up until now, when we work with acids, I say to you, well, hydrochloric acid is a strong acid, phosphoric acid is a strong acid, vinegar is a weak acid. But what makes that one acid is a strong acid and another acid is not? Well, it's an inherent chemical property. You should know at this point that when I take an acid, like hydrogen chloride, and I add it to water, I get H3O plus chloride. Okay? I can also, hang on for a moment, write it like this. What do we call this process when an acid breaks up and it forms ionization? Okay. What happens during ionization is my covalent compound breaks up. The hydrogen attaches onto the water. Now we've done bonding. Okay, there. That's it with a coordinate bond. All right. And there, how many? 1, 2, 3, 4, 5, 6. So here comes my proton that has lost its electron. Okay. It's got a positive charge, and it goes and it forms a coordinate bond. Are you with me? Okay. So normally when we write acid-base reactions, we don't show the water because all our acid reactions are in water. They have to ionize before they can react like acids. But it's not the water as such that is causing the reaction. It is this hydrogen ion. Okay. So normally when we write acids, we don't write them like that. I can. It just makes it more complicated. All right? We usually write them like this. So, we then know that when we add an acid to water, it will ionize, which means it breaks up into ions. If I take sulfuric acid, it will break up and it will form 2 hydrogen ions and a sulfate. No, I'll show you in a moment. If I have phosphoric acid, let's take nitric acid, HNO3, it's going to ionize and it's going to form that. And let's take phosphoric acid. because those are the ones that you work with. And I need another one. What's that? Vinegar. Chuku. Okay, now, here I have some of the acids and shown how they ionize. Now, vinegar is a weak acid, okay? The other acids, the mineral acids, they are all actually quite strong acids. pHs ranging from 0, 1, 2, maybe 3, okay? Why is vinegar a weak acid? And why is hydrochloric or sulfuric or nitric or phosphoric a strong acid? It's got to do with the ability to ionize. Okay? Strong acids ionize completely, which means if I have 10 molecules of this stuff, it's going to break up and form 10 protons and 10 chloride ions. It ionizes completely. Vinegar is a weak acid. It means it'll ionize partially, implying if I took 10 molecules of vinegar, maybe 3 will ionize. The other 7 is going to remain in that form. Okay? So strong acids ionize completely. Weak acids ionize partially. So, a base. What happens to a base when I add it to water? Does it ionize? No, a metal oxide or a metal hydroxide is already an ionic compound. But what do these ions do? If I take sodium hydroxide, let's take oxide. It doesn't matter, okay? It's going to dissolve, okay? This crystal is made up out of sodium ions and hydroxide ions. The ions are going to separate. So I'm going to get sodium ions and hydroxide ions. We can't say it's ionized because it started out having ions. But what did these ions do? They dissociated from each other. If you dissociate from somebody, you separate yourself from somebody. Okay. So, if I add bases to water, they dissociate. So what's the difference between a strong base and a weak base? Yes, strong bases will dissociate completely. Weak bases will dissociate partially. All right? One more term. What is the difference if I mean I have a dilute or a concentrated acid in comparison to whether I have a strong or a weak acid? Does it mean the same thing? No. What does dilute or concentrated mean? If I have a concentrated acid, I've got lots of acid, little bit of water. If I have a dilute acid, I've got a little bit of acid, lots of water. Okay? But if I have a strong acid, whether I have a little bit of water or lots of water, it's a strong acid. It ionizes completely. Okay? Do you follow? All right. So, acids ionize, bases dissociate. The strength of an acid or base depends on its ability to ionize or dissociate completely or partially. Strong acids ionize completely. Weak acids ionize partially. In grade 12, we do a section on chemical equilibrium. And then we'll go and have a look at this total ionization or partial ionization once again, from a different sort of angle. Okay, and we'll have a look at that. But for now, just very simply, strong acids ionize completely, weak acids ionize partially, strong bases dissociate completely, weak bases dissociate partially, and then whether it's dilute or concentrated implies you've got either lots of water or a little bit of water. And if it's concentrated, you've got a little bit of water added. If it's dilute, you've got lots of water added. I can have a strong dilute acid, and I can have a strong concentrated acid. All right? I can have a concentrated dilute, a concentrated weak acid, and I can have a dilute weak acid. Vinegar is a dilute weak acid. The one you buy in a bottle, I think it's like about 5% vinegar. It's like of the laboratory reagent, pure CH3COOH. Right. Don't confuse the terms. So in your textbooks there, on page 75, strong and weak acids. Now, they don't use the words ionize completely and ionize partially. They're on the right-hand side, the second paragraph. They say acid strength of the pH of the acid. This is caused mainly by the structure of the acid molecules, although mixing any acid with a lot of water will increase its pH. So we can have concentrated ethanoic acid, which is a weak acid, but dilute hydrochloric acid, which is a strong acid. All right, please write in there, strong acids ionize completely, weak acids ionize partially, strong bases dissociate completely, weak bases dissociate partially. Okay, now, there is a section that is not in your text, and it's higher level work only. So, how many higher level candidates have I got left? Then I don't have enough. No. Do the work, it's not, you can just write it down, I'll hand it out with the questions. I'll quickly do the work and then I'll go and photostat it, okay, because I'll stop at this point. Okay, now, back to pH. When I write pH, I write it like that, because it's got something to do with the proton. All right. The formula to calculate pH is minus the log of the hydrogen ion concentration. All right? So, if I have hydrochloric acid, of which the concentration is 2 times 10 to the power, let's just make it easier, 10 to the power 3 moles per cubic decimeters. Okay? This is just random. How will I work out the pH? Well, HCl, if I have this concentration, it's going to break up and it's going to form hydrogen ions and chloride ions. Yes? No, alkaline. No, we will only work with those that are water soluble. All right, our syllabus will limit us to those. They'll dissolve in the water and then they will react, yes. Or as they react, they will dissolve. Because some carbonates are not soluble, but they do react with acids. But it's in a watery medium because the acid is in a watery medium. And then the product is usually soluble. Okay. Okay, now, if I have a concentration of 10 to the power 3 moles per decimeter cubed. So if I have 1 cubic decimeter, then I will have 10 to the power 3 HCl molecules. Are you with me? Okay? So, when it ionizes, I will have 10 to the power 3 hydrogen ions, and I will have 10 to the power 3. Now, pH, I'm not interested in the chloride ions. Hello. Okay? I'm not interested in the chloride ions. I'm interested in the hydrogen ions. And how do I work it out? pH is minus the log of the hydrogen ion concentration. So if my hydrogen ion concentration is 10 to the power 3, actually I must have minus 3 just to get the calculation correct. All right. Then if you feed that into your calculator, the answer is going to be 3. All right. Have you done a little bit of logs in math? Okay, so it's not a strange calculation. Now, if I say to you, I have sodium hydroxide, what is the pH of sodium hydroxide? How do I calculate pH? pH? Now, there's one thing that when we do equilibrium, I'll explain it to you further in detail. But at this point, because in watery solutions, there is a so-called equilibrium. We have that the hydrogen ion concentration times the hydroxide ion concentration is always equal to 10 to the power minus 14. Okay, so this is like a rule that you need to remember when we start doing acid-base calculations, especially pH calculations, because I can ask you to calculate the pH of a base, and pH is minus the log of the hydrogen ion concentration. Or, no, if I have the ion concentration, can you see that I can work out that one? Okay, let's say I said my hydroxide ion concentration is 10 to the power